Hi, I'm Lucas, an AP Calculus PC student who makes these videos to help myself study. So today we're doing the derivative of an inverse. So this topic is actually pretty tricky for some people, but I can try my best to break it down. So first, let's remember the properties of inverses. So first, it's a reflection over, I'm not going to write all this. It's a reflection over the y equals x line. So if you have like a graph, you have y equals x. So if I have a parabola, when x is greater than 0, it's going to be like this. See, reflection over this. So that's one of the properties. The second, and this one is actually, I didn't know this, but it's g of x. See, you see this composite function, right? It's equal to x. Pretty interesting. It's because the domain and ranges switch. Alright, so that's the basics. Those three. Also, the third one is domain and range switch. So, I'm assuming you guys already know how to find inverses. And so, one thing you might not have heard of is monotonic. So monotonic means that the inverse is strictly increasing or strictly decreasing, right? So it means like the actual graph as well, right? Is it strictly increasing or strictly decreasing, monotonic? So an example of that would be if I had x squared, things not strictly increasing or strictly decreasing. So that's, not monotonic. That's the reason why its inverse has a domain restriction. If a graph is not monotonic, it cannot have an inverse without a domain restriction. So let's get into this. How do derivatives tie into this? Well, if I have, let's see. I'll use f of x equals x squared. We know f prime of x equals 2x, right? And so, with this, let's see. Let's find when x equals 3, right? So, f, well, like the derivative at x equals 3, it's going to be 6. Well, we know the inverse is this, right? And so, let's see if we can find the inverse's derivative, right, at x equals 3. So, let's try that. Hold on, let me kind of zoom out a little bit more. Hold on, let me just move this. Okay. So, we know the inverse is, hold on, I'll do -1 right here, is root x, right? So it's basically the same as x to the power of 1 over half, 1 over 2. And then let's just get the derivative of this. It's going to be 1 over 2 x negative 1 over 2. Simplify this, you're going to have 1 over 2 root x, right? As the derivative of the inverse. We plug in 3, and let's see here. 3, yep. Oh, sorry. I made one mistake. And this is something that a lot of people are going to get tripped up on. When you get the inverse, the x value now becomes a y value. You see, that was one of the properties that I had. So first let's find the x value for this inverse, which is just the y value of the original function. So it's going to be 3 squared equals 9. So we plug in 9 for x, and this is going to be 3, so you're going to get 1 over 6. Now, do you notice something? The derivative of the regular one and the derivative of the inverse are reciprocals, right? So that's how we can get this rule. So, yeah, I got some notes over here to remember all this. Lesson plan. Alright, so let's say I have g prime of b equals 1 over f prime of a. And this is if you have the coordinate point a, b. At first, this looks kind of confusing. I'll be honest, it is kind of confusing. So that's a totally fair assumption. But let's put this into words. All right, let's see what this is. Let's see. All right. So I have a problem for you. Now, along with this problem, I also have a special guest. Now, this special guest is a friend of mine who wanted to know more about derivatives of inverses. So let me just get him real quick. So this is my friend Malin. He also takes AP Calculus BC. Malin, say hi.
Hello?
All right. So we're gonna do this problem together, all right?
Okay.
So let's see here. If I have f of x equals sine x, right? And there's a domain restriction, but let's ignore that for now. And we want to find when we need to find a. Okay, so we're gonna be given the number here. Let me write a semicolon. A equals 1/2. This makes sense, Millen?
Uh-huh.
Okay. So then we need to find f, like the inverse, -1 prime of a. So this is like the x value, basically, right? But since this is for the inverse, it's actually the y value. So right now, for the main function, we're given the coordinates. We don't know the x, and then 1/2. Does this make sense?
Yeah.
Are you sure?
Mm-hmm.
Okay. So let's try to find this value, right? Make sense? We want to find this
Okay.
value. So let's just complete the coordinate. And we know this is the y value for this function. So we're going to have 1/2 equals sine x. Now, the reason I picked this problem is because you have to use a bit of unit circle. So what would x be?
Let me think. Uh, is it pi 2/2?
Not quite.
I mean, square root of 2/2.
Not quite. That's actually the coordinate. What we're trying to find is the angle in radians. So x would be pi over 6. Because remember, sine
Oh.
is like the y coordinate on the unit circle.
Mm-hmm.
Now, all right, here. Let me get the eraser. Let's erase all of this. We don't need this till later. So now we know the x value. So we have pi over 6 and 1/2. Right? So now we want to find the derivative of this. So, and this is where the shortcut comes in. So we have prime x equals negative. No, that's for cosine. I'm sorry. Cosine x. Now f prime. Let's see. Pi over 6 is going to equal. Here, let me erase this. It's going to equal. Let's see here. I got to think about this. Root 3/2.
Mm-hmm.
Right? This makes sense, Millen?
Yeah.
So this makes sense, right?
Yeah.
Okay. Well, with this, if you remember the shortcut where it says, sorry, g of b equals 1/f prime of a. Now remember
Okay,
how
yeah.
I said that a is the x value for the inverse, which is what this is. This is the inverse. So you could also write it
Mm-hmm.
as f -1, right? But it's also the y
Mm-hmm.
value for this, right?
Mm-hmm.
So what we're going to do is you take this, right? You do 1
Mm-hmm.
over this. So 1 over root
Oh.
3/2. And that turns into 2 over root 3. And this is your answer. Does that make sense?
Wait, what do the A and B mean in the shortcut?
In the shortcut, so basically, this is like the x value of f of x, right?
Okay.
That makes sense?
So it's your original function,
Yeah.
x?
And this
Okay.
is the y value of f of x.
Okay.
So when you write this, we would write, and there's numerous ways to write this, f prime of x. So what you're doing is finding the derivative of the inverse, right?
Mm-hmm.
Using this shortcut, and then you'll input, where's the y value? Pi over 6. Wait, no, you'll do 1 over 1/2. Yeah, you'll do 1/2 because look at the shortcut. A is pi over 6, right? Because that's the x value of the original function. So I should
Oh.
probably make these x and y. I'll make these x and y. X, y. So you put the x value right here, and it's the y value right here. That makes sense?
Yeah.
So that's how you get your answer.
So it'd be 1 over the square root of 3 over 2.
Yeah, and when you simplify that, you get this.
Oh, okay.
Some teachers don't really want the root 3 on the bottom, so you can multiply by root 3, and you get 2 root 3 over 3. But some don't care. So that's how you do it. It's kind of a mouthful, but it takes some getting used to. Of course, for this, I feel like this is the prime problem to do practice problems with. I feel like with a lot of other things, you could have gotten away with not doing practice problems, but this one you really need to practice so it gets ingrained in your head. Do you agree, Millen?
Yeah.
Thank you. So that's it for today's video. This one was a little on the longer side, but there was a lot of content to cover. So yeah, thank you. Bye.